Wow. They said they knew you that you were also a lecturer. That's interesting.
Hi guys.
Yeah,
Yeah.
that's like yes. So Victor is currently doing his masters in South Africa. Yes, so yeah, thanks. Yes, so he's currently doing his masters in South Africa, and he's going to be taking us on the Python session, the Python coding session today. That will be the first session before the second session. So a round of applause as we welcome him. But can go ahead.
All right. Hello guys. Can you hear me? Great, great, great. I'm super excited to be here today, and I want to crave your indulgence. It's going to be a long section with me. I have quite a lot to share with you today. So I'm trying to share my screen now. So just give me a sec, please. So I have quite a lot to share with you today, and I just want to crave your indulgence to give me your attention, and just going to share with you some of the things that you may need to know as you build your career. And I'm so glad because this is my roots. I'm so glad to be here. I was also once like you, and I'm still like you anyway. Yeah, so I want to be sure that we are all really ready to learn. And one of the things I usually share with you guys, even while I was still always coming to your classroom, is to emphasize that the need for you to be open to learning. There is no rocket science to these things. You have to be ready to learn. And if you're not ready to learn, of course, it's all your choice anyway. So, without further ado, we'll talk more better on my second section with regards to that. But I don't have much time, and I want to just plead that you will pay attention and pick something. Pick something. Let this inspire you towards your career projection. All right. So, the first section I'll be taking is on Python. Please, can you see my screen? Please confirm. My full screen on my slide. Hello, can you hear me?
Yes, we can. We
Okay,
can.
great, great.
Great.
So I'll be talking on Python for structural analysis, writing your own code. Have you ever wondered when you use put a structure, right? When you use other beam system, when you use the beam system for what you do, in structural engineering. Have you ever imagined what's the basis behind beam? What's the base behind CAD? What is the base behind all this software we use to run our analysis and all? Have you ever thought of what is actually the science behind these things? And that, of course, that's how we should think as engineers. We should always be critical. We should always ask questions. And because of the questions we've been asking over time, then we begin to ask ourselves, what then is the secret behind this thing? You know, of course, certain people, certain engineers actually sat down one morning and they was like, what's happening? We run a process and we keep doing the same thing over and again. Why can't we just create a system? Why can't you just create a platform where you can just insert your parameters and then you're able to automate the process and it just keep doing it for you over and again and you don't have to go through the stress of doing it manually. And that what brought about the questions. Okay, let's synergize with other guys in the science, in the science fair. Let's work with them and see what we can do. So engineers, took a step to electrical engineering with computer scientists, and they were like, "Oh, let's put something together. What is the system of automation?" And of course, that is a subject as a course from the computer science, right? And then we saw that, yeah, we could automate these systems. We could solve our problems in a more dynamic, in a more optimized dimension. And that was the genesis behind writing a system, writing programs that computer can understand, because the only language that computer do understand is its own language, of course. So a lot of things are going behind the screen for it to interpret the English you read on the screen. So for us to be able to now insert engineering terms, engineering parameters, mathematical, statistical data, for us to now work with it and then automate our processes always, we need a programming language that can help us simulate or optimize this process. And one of those languages that computer understand is Python, Python programming language. Of course, we have different levels of languages. We have the low, we have the high, and of course, with the low, you need a compiler for the computer to understand. But for high, straight off, it gets to understand, just like you're speaking senior code, just like you're speaking English to read, right? So that is one advantage with Python. There are quite a lot of them. We have a whole lot, but I'm not going to dive to that. I'm just going to focus this class on Python. So Python for programming, for structural analysis, for structural engineering. So these are some of the things we look into. Okay, I've tried to set a background to the conversation, and we'll try to wear our helmet because we are always known for helmet, right? So we'll try to wear our helmet at some point, and we'll just look at how these things plays out. And for those who would be interested to go further, you will see at the end of the day, and of course, you will see at the end of the day. Yeah. So I've laid a background to that, but just to take it a bit further into Python now, because we really need to understand how Python works. But for some of you, you might have probably looked behind you to see if you are safe and hope a snake is not beside you. No, 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 no. We are not talking about a snake, right? The first time I had Python, I was a tech up when I was doing an internship when I started learning programming back then in 2021, right? And when I had Python in the tech hub, I was like, "What's Python? You guys are talking about Snake." I look so dumbfounded. I look like a fool at that point. But I thank God I asked that question because changed uh, that changed my trajectory. That changed my focus at that point to begin to look at the angle of engineering and technology in a proper dimension. So Python is not a snake. So what's so special about it? Why is it so popular? Why do you have to learn it? Why do I have to learn it? Is it just a concept? Is it a tool that I can use? And that is where the point of interest is. We want to create tools. I said that background the other time. We want to create tools that we can use to make our work more dynamic, more optimized, to make us be more productive. We don't want to work so hard without being productive. We want to work smart and productive. So it's a programming language, of course, that you can use to optimize your process. You can write scripts, you can write codes, it's programming. You are training your system. Work this way. I want it to work this way. This is one of the things that Python can do for you. So instead of manually loading calculating your load, the reactions, all these movements, bending movements, the shear forces, you are visualizing your data in terms of your drawing graphs, and of course, most our language in engineering is in graphs, it's in statistics, right? So that is where we drive the most. Yeah. So you can automate all this process, you can simulate all this process, you can model this process using a programming language called Python. And why, for us to be able to do this, one major thing we work with is data. All right. So you want to be able to get control over your data. If you are working with structure, for instance, it's a very beautiful software, right? It's a very, very beautiful software. I use it a lot, right? But the truth of the matter is, it cannot work on its own. And it's not even safe for it to work on its own as an engineer. You will be putting the life of the people in jeopardy if Potter structure is the one controlling you. And I'm sure Engineer Caleb must have guided you thoroughly on how to make use of softwares as such. But what about if you intend to, I don't want to make use of these ones because something actually came together to build this structure. And that's what you are saying here. So why can't I just develop something that I can work with, that I can train, considering certain conditions, considering certain factors that work best for our own environmental, system, for our own ecosystem, because the truth of the matter is we need to start working with reality and durability in our design philosophy. Over time, over the years, we are so focused on prescriptive design system. But this is the time everyone. It's not look as if it's only only us in Nigeria that are left with left behind, because others have left are beginning to move from descriptive to durability. So a lot now are working towards durability index approach, and we are still at this point trying to we are still being we are still getting instruction based on what we are given, but rather to work with realities. And so for us to be able to actually maximize, so for us to play well in the durability approach design system, we need to be able to get control of what we are designing. When you are designing, do you even know what you're actually designing for? So this is one of the things that maximizing how to use, how to manipulate your data, how to read your data, how to process your data, how to visualize your data, how to think smartly, how to design smartly as an engineer becomes more realistic with you, more efficient with you, right? And of course, to every language, there are basics, all right? There are fundamentals that you must understand. It's just like learning English language. I could remember vividly when we were in primary nursery school. I could remember right now how we were learning alphabets, how we were learning phonograms. So that actually played a role in the English I'm speaking to you right now. If I had not learned that when I was younger, probably I wouldn't have. I met with someone yesterday. We were in a seminar, and this guy is from Germany, and we were speaking. And one of the things he came to do, he came to spend 4 months in our research unit, and he was telling us that one of the things that he needed to get his certification when he returns back to Germany is for him to understand how to speak English, to pass his English test. So, now we're not like, oh, please let's assist him look at this and that. And we need to start, for him to start learning the rudiments and the basics of English language. And I was just smiling. The same thing applies to every language you want to learn. The same thing applies also to Python as well. You want to learn how to use Python efficiently and professionally, you need to understand the building blocks. And the building blocks start from understanding the data types. Data types are like alphabets, right? They are like alphabets. Then understanding the data type, then how to manipulate the data type is now how you are able to make use of variables. All right, how much you understand variables. If you understand variables, understand data type, you will know that they work hand in hand and they are inseparable. You can't separate the two, right? Then from there you can move to list. These are other building blocks in Python that will help you to build a system. Loops, functions, right? Dictionaries. These are some of those building blocks that you need to understand. And it's also interesting to tell you that that same product structure that you know, the same Orion that you know, and any other sophisticated software, Abacus. I don't know if you know what Abacus is, and some other simulation software. Most of them are founded on the algorithm programmed with Python. Okay, so and then once you understand this system, these building blocks, you can then understand what library means. I personally don't would advise you to start engaging so much with libraries when you are yet to understand these basics, right? So library is just to make life easy for us. One of the things that is so interesting about science, about technology, about engineering is that we can always optimize our process. The essence of research we do is optimize process, is to make our technology better. The research I'm currently running is just to make our civil infrastructure system, our material technology more efficient, more optimized, more better, to have more solid and formidable, structures and civil infrastructures generally. So that's the same thing. Yeah, that is the role the library is playing in Python. So libraries are just like archive of functions, archives of components that you can call to, that you can pick and say, come assist me with this. Oh, I'm trying to plot a graph here. You come do this for me. You can just call on any of them and they can come around and help you. NumPy, you need NumPy a whole lot of time when you're going to be manipulating data. You're going to be working with, statistical data. This is where you'll be working with matrices that you, and of course, you remember what matrix is in mathematics, where you begin to probably you are summing up a number, you are adding up, you are multiplying a number, you are dividing a number, what have you, whatever analysis you need to run, you will need NumPy. You can't do any analysis without it. Like, it's just numerical, Python function. That's what it means. NumPy, numbers, numerics, and Python. Okay, and then Matplotlib is also another example of libraries that is very, very relevant for us in civil engineering, in structural engineering, which we can use to visualize. I told you the other time that one of the language we speak a lot. It's in numbers, percentage, uh, uh, graphs, statistical data. That's our language, right? So those are the essence why we need to understand how Matplotlib also works. So I mentioned two libraries now that you should be familiar with. You have to be familiar with the two. So I hope we are still on the same page up to now. I need a feedback, please. Any feedback? Are we still on the same page? Are you lost? Am I too fast? I need a feedback, please. Are we still on the same page, please? Okay, great, great. So now let's get a helmet. I hope you didn't drop your helmet at home. Are you all with your helmet? Feedbacks? Your helmet, are you there with it? Okay, so the first thing we want to do on on our hands-on is to set up our IDE for writing Python code. Excuse me. IDE means integrated development environment. Like integrated, it has the component that can allow you to write your code for the computer system, for your operating system to interpret. All right. So that's IDE. They are compilers in its technically they are compilers. Yeah. All right. So for the scope of our section here, we're going to be using Google Colab. So what we will do is just go to Google and search for Google Colab. Okay. So if you're with your system, you can be doing this with me, right? As you're listening, as you're watching, just go along with me. I will try not to be too fast, but you also need to follow me. Just pay attention, right? You will have enough time to practice this after the section. Just make sure you pick the main thing so you don't get lost at any point you're practicing. All right. So when you click on that, it brings you here. So I think it's integrated with your email. So if your Chrome is logged in to your email, you should be logged in automatically. But then if you have to log in manually, please go ahead. Just log in with your email, and your drive should be connected to it as well. It's all it's a Google product, so it's all connected. So you're good. So the next thing you want to do is to either open a new notebook or you open the application itself. So you can just from here jump on a new notebook. So here we use the term notebook, right? For each for a new project you want to do. It's called a notebook. So once you open a notebook, and just to let you know that we have different platforms, right? We have Jupyter, we have Anaconda. You can even use VS Code. All right. Probably some of you that are already into programming, you might understand what this means. Jupyter. This is Jupyter. Let me just show you on Google here. Yeah, this is Jupyter. So you can use Jupyter Notebook, as you can see on my system there. Okay, let me just go to the site quickly. So this is Jupyter here. You can use it to write your code. You can use Anaconda. You can install Anaconda. Not like they're all using Jupyter engine anyway. So you can go and download VS Code as well. Yeah, VS Code, yeah, Visual Studio Code. So we can explore all of these, but really time will not permit us. So that is why it's a boot camp, and definitely that for those who will be getting inspired, who will be picking interest in this career path, there will be a provision for each and every one of us to towards the post camp for us to go deeper, okay, and explore more options. But for the essence of this camp, we are going to just stick to uh, Google Collab, right? So one advantage about this guy is that it's on cloud. As I'm working right now, I can save this and share the link to you over there, and you can work with it many miles away from where I am right now. So that's the interesting part of it. It allows collaboration across borders. All right. And you can write your code, and it has a Canva that you can visualize whatever you write. So this is the interface, and if you are so familiar with Google Doc, you are familiar with Microsoft Word, any Google product that you're familiar with, and you've worked on, you should be able to work with these as well. They are just they're the same word that you see every now and then. You are familiar with file. You know, when you open file, you get some fundamental information you need. Maybe you want to locate a file in your drive, you want to open a new notebook, you want to upload a notebook that a colleague sent to you, and you want to continue work on this. You can open it up, or you can just use the link and get into it if you have access. And you can rename, you can change the name here. You can just come here and say, okay, this is University of Abuja uh, bootcamp practice. So you can just change that and they are good. You know, it's safe. Right now, this work is saved to my Google Drive, right? So I can always access it anywhere. I can share with you as well. If we need to work, if we need to collab, as what implies collabs, right? So you can move to trash, you can save a copy in Drive, you can save to GitHub. If you know how to use GitHub, it's a control version system that can allow you to update and push and all and do all stuff. Then you can download. So you can download in two formats. Either this is Python format. This is also a Python format, so we can choose any of those. But interestingly, you can go with py extension, and then you can print. If you need to print, probably you develop some some uh, some visualizations and you want to print out. You can see you can easily print and save as PDF and share with colleague for presentation and all. And that's how to work smart as an engineer. So other tabs that are there is edit. I'm going to let you know what cells are, so you can edit or say all these things are shortcuts. So sometimes you might just get familiar with shortcuts to make work easier and shorter for you. Okay, and then you can view in different formats and all. It's all options are there. You can just explore those ones. You can insert new code cells, text cells, what have you, code snippets just to get some code samples and all. The runtime, you can run your code. Maybe you have series of code, you can run the one before a cell or after a cell or everything together. If it's a bunch of complete, if it's a bunch of if all have to work together to give your final result, then you run all and then you just work, just play around these things. These are familiar things. These are things you're familiar with and all, you know. So then I was talking about cells. So these are cells. They are like boxes where you get to input your code. You can have a new code. You can have a text are text where you can put some just like README file. You can put some descriptions and all, you know, just to probably explain what you're doing. But there are other ways you can go around that. That's smarter anyway. And then you can write your code there. You can create a variable, then print out the variable, what have you. So this is the interface. And once you are done, you can click on this play button. It's just like a run button, okay? Just or shortcut control enter, and then it runs. So this is the interface. I just need to show us to see how it works, so that if you are logged in right now, if you are already on this same page with me over there, you can when I get back to my slide and I'm showing you some code snippets, you can be practicing alongside. All right, so that we can maximize our time. All right, so having said that, I will just go back. Is this clear? Is it understood? Let me get a feedback, please. Is it clear, or am I too fast? Is it clear? Great. I know I'm dealing with smart guys. Right. So we'll come back here. So we've set up our IDE. We are good to go. We are going to show our muscles and do like the way we see it on American movies. And then we'll do that. Then next week we'll look into deeper is the building blocks I explained earlier. We're going to look at it and how we can interpret them into solving real life problems and all. Then we just do it yourself, make our space. We import libraries, of course. We analyze some examples, just one or two. Then you practice. I leave it to you to continue, right? So, comments. The first thing I need to emphasize on is comments. You must learn to comment on your job. All right. And how do you do that? There are two ways. It's either you use a single line or a multi-line. And I have taken my time to write out this in my own code snippet, and that's what I'm sharing on the screen to let you see instead of shoveling in two screens, then going from here to back to screen. That may take some time. So I've tried to write those code out before now, and then put them in this snippet for you to see how it's being written. So if you are commenting using a single line, you can see on my code snippet. Code snippet is the one is that picture that looks like a code on the screen there. Yeah, that's the code snippet. So if you look at that, you will see that on line 1, I wrote hashtag single line comment. This is a comment. That means that is how, if you want to comment out, that's how to write a comment. And some of you who are not familiar with this programming world, you may be wondering what comment means. The meaning of comment is you are telling Python compiler, you are telling Python that once you want to run my code, you see these guys that I put in comment, don't touch them, just leave them alone. Ignore, do as if you didn't see them. So it's just like when you try to greet someone and the person snubs you. I know some of you have done that before, right? So you can relate right now. So that is exactly what Python is going to do to those lines. So they can be codes, they can be text, they can be description. Personally, when I'm writing a code, I love to comment. I love to put what I'm doing. I wrote some code over the week, and if I don't comment those things I did there, if I go back to it right now, I might have forgotten what I was doing here. And the same thing applies to when you are sharing and this is a collaboration system, where you can work with other engineers to rub minds together and solve a problem. That's what we are known for. So you can be doing something and you send to the other guy and it's like, gosh, what is this guy? What do you do here? This is not my own style of writing. I'm so confused. But once he sees the comment you made, he will be like, oh yeah, this is what you're trying to do. Nice approach, nice approach. You can then build on that. Even for your own self as well, for you to remember yourself or to remind yourself, what you've done here before and all. So that is a good practice and it's one of the best practices. Comment. So you can use any of the two. So if it's a one-line comment, just hashtag it and you're good. But if you are writing more than one line, it's a long comment and it's going to be taking some lines. It's not reasonable. You can, but it's not really reasonable to be using hashtag everywhere. You can just use 3 apostrophe on the top and 3 apostrophe after the text. And then it's going to comment it out. That's a multi-line comment. I hope that is clear. So the next is variables and data types. I was mentioning the other time that the fundamentals, the fundamental to learning any language is understanding the data type. And across all programming languages, JavaScript, Python, C Sharp, what again? We have a whole lot of them there, right? So one good thing about them is this data type of the thing looks similar. So for me now, I started off from JavaScript as my programming language, which is one of my favorites. So, but then when I started learning Python, I discovered that wow, it's quite easier for me to learn because it looks like their language texture or components are the same in a way. So what I'm trying to say is data type is quite a general concept in programming. So if whenever you see int in a programming language, it means integer, which means whole number in mathematics. In fact, in mathematics, it's actually integer, but we are taught as we learned it as whole number. So that's just to break it down to make it simpler. So whole number without decimals. Okay, so you can see on line 2 on my close snippet, you will see that I wrote 10 somewhere, right? So, but then for me to just carry both of them along, I'm going to now explain variables as well. So variables are, when you hear the word variable in programming, you can imagine a box. So when you have a box, like maybe Joker, is anyone being Joker there? Is having a birthday party tomorrow, Sunday, and then right now, Frank, you're already thinking of giving her a present because she's your friend, a good friend of yours, you know. So you going to ShopRite or Pick and Pay to pick up a box, probably a wristwatch, a golden wristwatch, and then of course packaged in a box, right? You see that box represents variable. Okay, so opening up that box, they have to be a data type inside inside that box, right? There has to be something inside the box. So that something is the data type. So it can be in different types. So depending on what you are trying to achieve anyway. So that wristwatch is the data type, and the box wrapping the wristwatch is the variable. That's how NJ. All right. So as I was saying, so we have different data type, and then there are variables. They are just accommodators. They are like the landlord that accommodates tenants. So it's either it's permanent tenant or it's a temporary tenant. You will understand what that means as we proceed. Anyway, so integers are a type of data type, more like without whole number without decimal, and then the other opposite to that is float. Float as decimals, okay, and this is more realistic in structural engineering because we are always out for precision, and precisions may not usually be a whole number. In fact, most time, if you are in the laboratory, you are running a test, you shouldn't be getting whole number because there is an allowance for precision, and this is the same mindset you will use whenever you are designing. Of course, most of the time when we are using our software to design, we work with whole number, 45 kilonewton. We work with 50 MPa, 30 MPa. Yeah, it's okay. But for precision, when you are doing actual analysis, you need to work with floats. They are just decimal number. You can see that on line 3 in variable f. So I said f is equal to 3.14. So bool is a Boolean data type, which usually is around logic. Is this true? Is this false? So you will always need that, really, because when you are running a particular, you are developing an automated system. You want to check logic, right? You want to be logical. And you want to check. You want to build a logical function that can check, is this true? If it's true, do this. If it's false, do this. Okay. Then we have strings represented as str. So for strings, you must always put them in quotation mark, double quotation mark. Okay, as you can see in line 5. Okay, you must always put them in quotation mark. They are just text. So anytime you are writing anything that is not integer or that is not float, you must put it in quotation mark. So what if I want to write 3x, but 3 is there now? Why should I put it in? No, you have to, for as long as x is there, that s turns that 3 to text. All right, to string, I mean. All right, so we don't use text in programming, we use string. Okay, so you turns that to string. So how about list? So list is just, if you are familiar with JavaScript, in JavaScript we call this array. Okay, so they are just array, they are ordered array, collection of array. So it's just as if when you go to supermarket now, and then before you get into the supermarket, at the entrance you see a trolley, right? So you just pick a trolley, and then you go taking selfie, looking around, picking this, picking wine, picking that, picking, that trolley represents a list. Okay, so you have dictionary as well. Dictionary are like objects, and to every object there is a property, and this is the core of what we do as engineers. So you are working with a steel, you want to design for concrete, all right, reinforced concrete. You are designing for a particular structural member. So for you to make decisions on when you are making decisions on the material you want to use, probably you want to use a particular grade of steel and a particular grade of concrete. So concrete is an object, and that concrete has properties. So properties are the characteristics in terms of the the material name, in terms of the weight of the material, in terms of those characteristics, those things that makes up that material. That is, for you to now accommodate that kind of variable, you need a dictionary. So dictionary is going to give you provision to create a key. Key is like that property. So, and then that property has a value. For instance, now steel, right? For steel, now you talk about elastic modulus. So what's the elastic modulus of steel? So when you mention steel as your as your material, so steel can be the name of that variable. So for you to now identify all the properties, you now have to define, okay, the elastic modulus is a key. So you put elastic modulus in quotation mark. Just look at line 7 and see the way I wrote it. So that A there can be like elastic modulus, then full colon, then 1. That one is like, what's the elastic modulus of steel? You used to remember? So if you remember, you put it there. Okay, so that's how to generate a dictionary. So you can have series of materials. Okay, for this project, you are working all the materials you are working with, you list them out like that. uh you can create them, each of them, then create their properties, and then their keys and values, right? And then you can manipulate, you can work with it as you go forward. Then there is another guy called Tubble. Tubble, they work like list as well. But one interesting thing about them is they work like consts in JavaScript. They are like constants. So once you set a tubble variable, you can't change it in the process of your uh, function. If you change it in any part of your function, it's going to throw an error to you that can't be changed. So that's one thing. So that's different between list and table. They all have their use. There are sometimes you'll be running some analysis and you want to keep certain variables constant, right? You know those you did analysis earlier before now, right? You did design earlier before now, so you will remember some of those variables that we needed to keep constant, like we talk about fixed load, right? Talk about some self weight load, right? So those dead load that they may not change over time. They are just self loading, right? So they are just dead load. I mean, they are dead load, so they might not change over time. They are always it will always be there. So you can keep those ones as stable for you to manipulate, so it won't change. Because if they change, it can affect your whole design. So that's the application to all these things. So then once you are comfortable with your learning, with your knowledge on variables and data type, the next thing you want to look into deeply is operations. Okay, so how do operation works? I need to start rounding up now, so please follow me. How do operation works? We have arithmetics operations. So when you talk about this is when these are the operations that were used to create NumPy libraries that we'll talk about later. But just on the fundamental, for you to even know how these things work. Arithmetics like addition, like subtraction, like multiplication. In programming, the sign for multiplication is what you see here. As you can see my mouse on. That's asterisk. Yeah, it's a multiplication sign in programming. Then you have division. We have etc. like that, right? Then assignment. What's the difference between assigning a variable and equal sign? In mathematics, we say equal sign is just this single equals, right? This equal sign is what equals that. This thing is equal to this. But in programming, a single equal sign means assignment. An assignment means I am telling you variable A to accommodate this guy. So I'm assigning this property to you. So if you look at um, if you look at line 3, where I said I equals to I plus 2, that means to I am assigning I plus 2. So whatever I is initially, once I add 2, that's what will become I. That sounds too complex. So let me break it down. It's just like saying A equals to white, right? So it's not that equals there is not equals. It's assigning. You are saying that keep this white for me. You are telling F or you are telling whatever you name that variable, keep this color for me. I will need to use it later. So that is what assignment does. That's why it's different from comparison. So when you are comparing, that is when you are using double equal sign. I'm on line 3 now. So I'm on line yes, I'm on number 3 now, comparison. So you have equal sign, double equal sign, you have exclamation not equals to, you have greater than, less than or equals to, less than or equals to, greater than or equals to or greater than. You have all those comparison, right? You remember them. So we have another one that is triple equal sign. I'm going to also tell you the difference between double equal sign and triple equal sign. So for double equal sign, you are saying that white is white. This variable is true. If it is true, do this. For you to confirm that, you have to use a double equal sign, not just one. If you are saying one, you are only assigning. You are not confirming. You are not making any comparison. So, but for the triple, you are saying that all the properties of this guy, this one must also have it. So you are looking at left and right, bah. You are looking at left and right. You are saying left must have the same thing that right has. So for that to happen, you have to give a sense of completeness. So that sense of completeness is where you use a triple equal sign. Okay, it's similar to double, but it's advanced than double. Double will just check is this value correct. Maybe you did an addition outside the function, and you are telling it, okay, go and check the global variable, check if this is correct. If it's correct, then run this function. So you can use double equal sign at that spot. I think that is emphatical enough. But and then if you want to negate any logic, you can use exclamation and then equal sign. That is saying if this is not equal to this, then do this. Okay. So as you speak that word in code in normal English language, you can code it out using these operation signs. And I wish we can have enough time to even practice writing. We'll speak an English and then we'll code it. We'll write the code using operations. That's an exercise on its own. Please pen it down for your practice. So logical as well, you always run logics. You always check, you always run loops and all. You always check conditions, conditional statements. Is this equal to this? If this is this, then that is that. Then do this and do that. And sometimes you want to confirm if a particular item belongs to a collection. That is using a membership variable. That is what I show on line 6. So that's the in. When you see is in list equals to 3 in 1, that in there is the operation, is an operational sign to check if 3 is in variable hell. Do you understand? So you may always need to use that depending on the kind of function you are programming for. And for the logical conditional statement that I was referring to the other time, operations, conditional operations I was referring to, you have the likes of and, or not. Do you understand? We did computer programming to 11, so that should not be a strange thing. So control structure, I've emphasized on this. I try to talk about this under logical, and this is also where you can apply it very well. If an S control system. So you are running a code and you want to see, look at my code snippet at the right side of my screen, where I said if I is greater than 5. See the way I wrote it, then I put a full colon. Then I jumped to line 3, but I didn't start writing in the same line with I. I gave an indentation. That is how to write a programming language in Python. Okay, a programming line in Python. So you give an indentation whenever you are beginning to step into a loop system. So you give an indentation, just one, then you can do whatever you want to do as your function. Okay, here just print I is greater than 5. Okay, S print, then whatever you want to do, you tell it to do. Okay, so if you depending on the conditions you are trying to set, the kind of boundary you are trying to look at, you can use that line of code. An interesting thing about VS Code and the likes is they help you to index properly. So even if you don't, of course, you should know how to index, but it can help you to code faster when you use extensions like Prettier, just to keep your work look well indexed and all. So another thing I need to talk about is full loops. Full loops is to run a loop. So if you are using a full loop, a for loop, just like you want to loop through an array. So let's say, for instance, you want to, what's the closest example coming to my head now? You are trying to keep a number constant, and you want to multiply a certain array to that number. So on its own, just once you multiply this, go and multiply that, go and multiply this, go and multiply that, go and multiply this, go and multiply that. To do that, you need a loop function. And that is where for loops comes in. For loops, while loops, they do almost the same thing, but it's just their syntax that are different. Syntax, that's one of the building blocks. They are called syntax. So the way we write in programming language are called syntax. Okay, so it all depends on your choice. You can use while loop for the same thing that for loop will do. You can see the way I wrote it in line 7 to line 10, and then from line 10 to line 13. Both of them are doing, I think, the same thing. Yeah, I think they are doing the same thing. So it all depends on how you are comfortable writing your own syntax. Okay, the same way you speak the same English I'm saying is maybe different from the way you will say it, right? The same way I'm explaining now may be different from the way you will say it. And this is engineering, this is mathematics, right? So having said that, okay, I gave a little more example here on loop control. How you can here for loop control, you can put your loop in infinity if you don't control it. So how do you control? These are the times you use. Either you break it out or you continue. So if this is happening, continue. If this is not happening, just break out. Okay, so these are the snippets. Maybe you can take time and look them again. Try to write it out. That's how best you can actually learn coding or programming. You have to write it yourself. You need to question each line to know what each line is doing. From that's how it sinks in. Okay, so this is the language you use, breaking out or continuing your loop. Then functions, this is where you are coming to at the end of the day. You want to start writing functions. It is when you are able to write functions well that you can build applications, that you can build the likes of product structure that fit into Nigeria ecosystem. So I'm already inspiring some of you right now to start thinking outside the box. So for you to be able to do all those beautiful things that you have in mind, you need to actually learn how to write functions. So functions, just the way the word implies, is a function. So it has a work to do. It has a role to play. So for instance, I want to create an application that can be calculating reactions on structural members. I want to create an application for that. I want to automate a system for that. So for me to be able to do that, you know what it implies when you are calculating reactions, right? Equilibrium of forces. That's what I'm talking about now. When you are doing that manually, you know you know how you need to break down your loading to a free body diagram and then identify the reactions playing out depending on the support systems, right? You know how that works manually. So now all those parameters you need to put in place, the multiplication, the addition you can do all those, like you can do it manually. You can write code, just keep them in variables, then print out your answer at the end of the day. But what if we need to do that many times? What if we need to do it in several places in our application? Do we need to start writing the code over and again? No. So that means we need to create a system that can help us just call on it and it will answer. And that is where function comes in. So function are like reusable, they are components, they are code blocks that you can reuse at any point in time you need it. So if I need to create a function that can calculate reactions for me, what are the parameters I need to calculate reactions? I need the force acting and I need the support system. So I will get those parameters, the params, and put them as the function params, and then create a function for it. That is what you are seeing on my screen, on my snippet. I know it's kind of might be confusing at this point, but just digest it for a while for it to make sense to you. So all the things you would do normally, the kind of lines of code you will write, you are bringing all of them and bringing them on a under a roof. You are giving them an accommodation and say, "Oh, all of you come and be living inside here." So whenever you need to call on you, they just say, "Go to that building, call that building." You get what I'm saying now. So whenever they call that building, all of you will just mix and all of you will interact, and then whatever it has been formed inside that building, inside that function, will activate and work for as long as you give in the correct variables that it's expecting for you to give. Do you understand? So look at this function I created now. I created a function for multiplication to multiply two numbers. You can see I collected just two params. So how do you now write functions? This is the code snippet. This is how to write it. You have to define your function. Okay, then what's the name of the function? You can write multiplication, just any name. So you can put any name to replace that my function that I wrote here. You can replace any name with depending on the function you are creating. Then what are the parameters you need? How many parameters would you need? Then name those parameters. So these params can be depending on what you are looking for. So it can be, let's say for instance, force1, force2, force x, force y, depending on parameter, the name of the parameter you are looking for, you represent it in that bracket. Then put a full colon, then what should it return? So that what it will return is the actual function, is the actual operation that is happening inside that function. So in this operation, I am saying anytime anybody call this function, my function, and give two parameters, multiply the two parameter and print the answer. That is what, just return param 1 multiplied by param 2. That's what it will give to you. So I practiced that on line 5. I created a new variable, my variable, and assigned it to this function and gave it two parameters, 2 and 3. If you print my var, underscore var, it will print out, what is 2 times 3? 6, right? It will print out 6 here. So I want you to think deeply now. Look through your theory, look through your structural analysis course, look through your straight of material course, all those applications, right? These are some of the ways you can go about it on your own without having to, for some of you that will be able to take this up, you might take a challenge up to even stop using calculator for the next 1 month or two and just use Python to carry out your operations. Just task yourself. It's going to be very hectic. It's going to strain you, but I can assure you, you are on a path to greatness if you do that. If you can't do that. So I talked about list the other time and dictionary. So this is the explanation to them. Examples, they are arrays, and there are different methods that you can use on that array. What method means is operations. There are different operations you can carry out on any of these, for any of these variables or blocks. So if you are working with list, what are the common method you can use? You can append. Append means you want to add to the variables. You went shopping, you carry A, you carry B, you carry C. You want to drop more into your basket. Dropping more into the basket is appending. So if you append and then you call out your list again, you see that on line 4, I appended this array, and the method to append to add is just my list dot append. That's a period. Dot means period. So my list underscore period append in bracket 4. This 4 means add 4 into this array. So if after line 4 I print out my list, I said print my list, it's going to print out this 1, 2, 3, 4. So why I didn't print some of these out for you to see is I want you to practice with them and print them out yourself to see. All right. So the same thing applies to line 5. I think that they're the same thing there. So for line 6, what this means is whenever you see a line of code written this way, let me explain. You see a variable with an index number. Index is when you see a square bracket and you see a number in it. What is telling you that go to this array and go and check for the index. Index is the position it is holding. starting from 0. So in programming, we start counting from 0, not 1. Hope that makes sense. So you are telling your variable you are telling your function to loop through the array and go to anyone holding the position of 0 and print it out. You get what that means? That is what indexing means. That's what indexing represents. So in this case now, I want to displace what is staying in position 0. And if you look at my original array in line 2, what is on position 0 is 1. What is on position 1? What is on index 0 is 1. What is on index what is on index 0 is 1. What is on index 1 is 2. What is on index 2 is 3. Does that make sense? So in line 6 now, I am trying to displace what is on line 0. I want to change what is there to 0. That's what I did in line 6. I want to delete from the array. That's what I did on line 7. So if I may ask now, on line 7, what is going to delete from the array? Anybody? What is going to delete from the array? Huh? Which of the number on the array in line 2 is going to delete? Are you sure? Remember indexing. Indexing in programming language starts from 0. So when you are numbering it, you start from 0, 1, 2, 3, 4, 5. So if I'm saying that I want to delete what is on index 1, what am I trying to delete? Anybody? Now, I'm trying to delete 2. Do you understand? When you see square bracket, it means index. And index means the position where the item that is on that position, the data that is on that position, on that index there, in the array, in the variable that you are calling. Okay, I mean maybe you need some time to wrap your head around that, but that's how it works. Okay, so there's difference between parentheses and square brackets. There are different between them. When you see square bracket in programming, you're talking about index, like where you belong, the serial number, the label number of that item in the array or in the object. So, and I've explained dictionary earlier. This is how it works. This is the syntax. So you can call on any position in the dictionary using that method, and you'll be able to print it out and make use of them. Yeah, don't worry, we'll go deeper into this in the post camp for those who will be interested in this line. But this is just to give you a grip of the interesting thing happening now in software engineering for us to wake up. Right? So I've explained Turbo. They are very immutable. They are very, very dangerous to joke with. Don't play with Turbo. When you set the Turbo, you are saying that you're going to be there for a while. Can't modify you. And then string formatting. This is where you can manipulate string. Definitely, at the end of the day, you want to print title of your graphs. You want to write text. You want to print some text out. You must know how to format strings. So this is a simple way to print it out. So if I want to print feature and the name and the age out, for instance, now these are two methods you can use on line 4 and line 5. So print, you can start with a parenthesis, then an F, to format your string. Then you put an exclamation, 2 quotation mark, okay, 2 quotation marks, and then my name. But what we want to make it dynamic, right? So it's going to pick the name from the variable set. So if you input your data, I don't know some of you if you have experience opening an account, and then when they open the account for you on your dashboard, they will tell you welcome. Then you see your first name, for instance, now Afiz or Aziz. Welcome, Aziz. So have you ever wondered how your name jumped there? This is the method they used. So that's when you were filling that form, they picked your name from the form you filled using this method. It's more advanced than this, but this is the fundamental to it. This is basic. Okay. And then I am this age. So I'm calling that variable in what's this curly bracket now? Yeah, in that curly bracket is representing the variable. So whatever you set as a variable is what we project out. So when I print this now, I'm expecting to see my name is Victor and I'm 30 years old. That's what I'm expecting to see. So you can either use the line 4 method or you can use line 5 method. Do you understand? So I think line 5 is very interesting to use. So you can play around the two of them and get used to it, either the both or one of them. All right. So okay, I think we've been doing quite a lot for now. Can we take a sip? Maybe just 30 seconds, just stretch your neck a bit and host. A lot is happening here. I'm even here to understand the strength of material. Now I'm hearing another thing. Yeah, I know geotechnical engineering is stressing you. I know. Yeah, I know it's a whole lot to absorb there. But now we are bringing programming language. I ran away from this into A level. Why am I coming to it again? Sorry. This is the reality with us now in civil engineering, right? So take a sip, and I'll be back in 20 seconds. All right, so let's continue. So we've talked about the building blocks. We can now look at, we can say an hi to library, and I've mentioned about this library at the background of this class. And I told you that there are two libraries that you must be familiar with, which is NumPy and okay, Matplotlib. So for NumPy, it's used to create or manipulate arrays, and the original data type of NumPy is a float. So you will see it here on the on the code snippet. Whenever you need to start your job, because definitely you'll be working with array, you work with numbers. Let it just sink into you that anytime you want to start working with number, the first thing you must type is import numpy as something. But usually we use the alias np just to short form numpy np np. Let that sync. It's a common alias, so you want to be familiar with that as well. So numpy as alias as np, I mean. So once we set that line, what we just did right now is that we have installed all the components that's inside numpy library. That is what we've successfully done. It's just one line, and you've called the function. Remember how we were calling function here, right? Yeah, yeah. When you call this function out here, that is the same thing you just did right now. So you just called out the function, you just imported it. You don't worry where it's coming from. It's coming from somewhere. Okay? Yeah, we can look at that on a deeper level later. But that's all what you must know and all you must do at the beginning of calling a library. So how then do we manipulate? The first thing you want to do is to check. I told you that they come in floats, and if you see, I just called zeros. Like I called 4 columns of zeros, just array of zeros. I just need like four of the rows, just 4 zeros, and that's what I did in line 6. I just gave a variable. You always assign a variable whenever you are writing. Whenever you are trying to manipulate any data, you have to store it in a variable. So I stored that in variable A and said A should store np period zeros in brackets. Zeros itself is a function. Okay, zeros in parentheses. Then inside the parentheses, I want 4, just 4. So if I print out A, it's going to give me 4 zero floats. So that's just always like a test to see that your MP is properly imported. Once you get that, then you can move on with your project. So this is quite a lot to start explaining now for us, but I'm just going to walk us through quickly. All right. So you can create arrays of lists. You you can do quite a lot. You can work with and you remember matrix, right? You can store you can store your numbers, your data in matrix form and work with it from that angle. It's just in arrays. Matrices are arrays. Okay, they are lists. Okay, but I will be using more of array and list, interchangeably, but they're the same thing. So and if you see line 2 and 3, that's just one dimensional array. But if you look at line 3, that's two-dimensional arrays. Okay, so once you remember how matrices work, that line 2 and 3 will make sense to you. You remember arrays are in rows and in columns. So if you are to arrange line 3 the way you normally write matrices, you will see that matrix 1, 2 will be on top, matrix 3, 4, 3.5 and 4.2 will be down, right? So that's like two-dimensional. So you have 2 rows, 2 columns. But one-dimensional, you have 1 row. Does that make sense? And you can also convert from one data type to another data type. Okay, you can do that on a normal data type level. You can also do that in arrays, as you can see. So I just call out some method there in line 6 and 7 for you to see how you can call arrays of zeros, arrays of 1, if you need to work with any of such. And then sequence that I need to also explain to you is line space and arrange. Line space is, for instance, if you are trying to plot a graph and you are working with a range of number. Okay, so you can say, okay, for line 10 now, I said A equals to NP period line space. Mind you, there is no E in the line, just LIN and space. Then I put some parameters, which is 1, 10, and 6. What that means is that I need a boundary of 1 on the lower level, and I need a boundary of 10 on the upper level, but I want you to spread it out in just 6 points. So you are looking for just 6 points, six values that will range from 1 to 10. That's what you are saying in line 10. But for in line 11, you are saying that arrange. You can see the difference now. This is NP arrange, but mind you, just a single R in the arrange, not double. Arrange 110 and 1, comma 1. That comma 1 is the way you want it to be arranged. So you want it in just a singular sequence, just adding 1 to each other, 1, 2, 3, 4. Do you get in that sequence? That is the difference between line space and arrange. Line space is going to distribute it evenly, while arrange is going to work with steps. I hope that makes sense. So these are other properties you want to check for dimension, for the shape, for the size, for the data type, or you want to convert data type, or you want to check the data type for you to manipulate it. These are the method you can look at. Do you understand? All right, these are other ways you can manipulate, you can modify, you can access elements. We'll talk more on this in our post camp. All right, I need to round up now. And these are other mathematical operations that you can look into. You want to do addition, you want to do subtraction, you want to do multiplication, you want to do square of numbers, and you want to do matrix multiplication. I hope you know there is a difference between multiplying elements and doing matrix multiplication. So if you have forgotten that, please, before the postcard, quickly go back to your 100 level mathematics to remember all those things. Okay? So because the application is what you'll be seeing when writing your own code. And you're able to write the code from the abundance, from the knowledge of this fundamental statistics and mathematics. Yeah, so that's the logic. Then these are other method you can use. Maybe you are trying to check on a column or on a row. These are the format. These are the way you can write it. Do you understand? So just look at the code and let it make sense to you. Okay, let it make sense to you and see a point of application. And mind you, can always ask questions afterwards. Yeah, these are other methods you can look at. You are trying to stack vertically or you are trying to stack horizontally. So I told you about stacking a matrix where we stack horizontal, where we stack vertically when writing. This is how you can now convert it. You can change the orientation using this line of code. I want A and B, matrix A and B to be on the horizontal stacking. Why I want a C and D to be on vertical stacking. So you can use this to manipulate that. Then you can do array, you can append, you can also insert, just the way we had in normal list. All right. So the same method that applies in our normal data type manipulation also works in NumPy libraries when you are using NumPy libraries. All right. All right. So we have a problem, practical problem I want us to look at and solve. This should be familiar with all of us. This should be familiar, right? This is introduction to strength of material. So the goal here is just to calculate the bending moment and shear of simply supported beam using NumPy. You're not using your calculator, you're not using the manual method, you are using NumPy. You're only using your knowledge of analysis and then a tool called NumPy in Python. So I told you that I think I mentioned it earlier that anytime you are trying to solve problems like this, you need to break it down to know what are the parameters that you will need. So what are the provisions that you have? You have a uniformly distributed load Q, and you have one span. You have one span of length 5 meters. Okay, that's the parameter that you're given. Just one span of 5 meters and uniform distributed load under simply supported beam. So you have 1 inch support and you have one ruler support. So how do you analyze that in structural analysis? Right? Do you remember this fibroid diagram? Whenever you are converting a loading to a free body diagram, a loading system to a free body diagram. So this is how to interpret it. So these are the parameters you need: the VA, the HA, the Q, the VB. The VA and VB is the shear forces, right? And then the H, they are the vertical forces, right? And then the HA are the horizontal forces. So how do we interpret that on hinge support, on roller support, and then how do we convert that to an equation? So you then use your knowledge of strength of material to convert this to an equation. These are the equation you are going to now create variables for in your lines of codes. So this is the way I'm going to insert this in my code. So this is going to be our task to do now, but I'm just walking us through how we're going to do it based on what I've explained. You are going to now create code for this, create variables for this to store each of these information. You can see you have HA. What's HA? You have it here. HA, this is VA, this is VB. So you are going to, mind you, subscript, yeah. So you are going to create variables like this for them. And so once you do that, you now derive, all these were done from the knowledge of structure of material. This is not coding now. I'm not even talking about coding now. I'm not talking about Python now. So you have to generate these equations yourself, these bending moment equations and these shear force equations. So once you generate that, this is how you now set up your, these are the information you will use to set up your code, your application, your code base. So the first thing you do is import NumPy. This is the solution to the task, but I need you to still do it yourself. You will import NumPy as NP. Then you set your primary variables, your primary parameters, which are the length of your span in meters and the value of the distributed loading, which is in kilonewton per meter. Okay. So then mind you, you are going to be producing your answer in tables and also in you plot a graph. Definitely you need to show your shear force diagram. I think that's the task, right? And then you need to show your bending moment diagram. So definitely you need to set the parameter for the x-axis and the y-axis. Do you understand? So you need to set the parameter for that. So on your x-axis, you have the value for the bending moment. You also have the value for the shear forces. All right, and on the vertical axis, you would have the value for your um okay, that's where you have your forces. And the x-axis, sorry, will be the length of your span. Sorry. The x-axis will be the values the length of your span, and the vertical axis will be the values of your forces. Do you understand? So shear force or bending moment, the values are going to be on the vertical axis, right? So you will now need to store them. You need to put the equation. You can see on line 7. Okay, on line 6, I mentioned the range of value I want to work with. So for the length of my span, which is 5 meter in line 3, I wanted more precisions, more accurate. Because sometimes when you look at proto structure and you've done your loading, you've run your analysis, and you want to check for the um, the real-time effects of deflection. There is a feature, there is a function in proto structure that can allow you to check for that. I'm trying to remember the name now. It's skipped my mind. So you will see how the structural element is deflecting. You will see the area that are quite concentrated and the area that okay, this one is withstanding, is doing fine with the loading, but this place is oops, you need to really reinforce here. It's making you to know as the how you should detail your reinforcement and all. This is the essence of line space, practical essence of it. If you don't give enough points where you can visualize what is happening in the minimum detail possible, you will not be able to know. Okay, like for instance, now if you are setting mesh, right? The best way to do is to ensure that your mesh as small as possible, not having too large area cross sectional area. You should have a small section cross sectional area as small as possible for you to be able to detect what is happening in that gross area. So the same thing applicable here. If you are solving this problem mathematically or manually now, you just work with your length of 5, you got your answer, you plot the graph 0 to 1, 0 to half, 0 to 2.5, and 2.5 to 5, right? That is your length, the length of your span. 0 to 2.5, 2.5 to 5, right? That's all you get. That's how you do it in straight of material. But if you are using this now, you can break down those points from 0 to 5 into 20 points because you want to get information of what is happening. Because this will help you to know how you do your design and also specify your reinforcement. I want to know where actually is having a lot of loading, a lot of deflection, so that you will not be over designing or under designing for all the parts. So this is modular design system now. Okay, design philosophy. So that's the essence of spreading your line space as much as possible. So it is that value that you have in X that you now use to calculate your M in line 7 and your shear force in line 8. So all you just have to do here, you have automated the process. You don't have to worry yourself. Just make sure that your formula in line 7 and 8 is correct. It will pick up the value itself from line X. From line 6, I mean, it will pick up the value that it will use for calculation from there, and it's going to look through, it's going to get all the values out. So line 10 and line 11 is how I want to print them out. I want to print out the answers. So before I show you how the answer looks like, I want to quickly chip in Matplotlib now. I'm rounding up. I want to quickly chip in Matplotlib that you can use to now plot the graph. And for you to import the matplot, This is how to import it. So line 1 and line 2 is how to line 1 here is how to import it from Matplotlib, import pyplot as PLT. So you will see the difference between this and this. Mind you, please. The difference between this and this, there's a difference there. So you are specifying that from Matplotlib, import this. We import the library of plotting in Python. That's what pyplot mean. Plotting function in Python as PLT. PLT is just an alias, right? Just a short form too. So that when you are calling it, instead of calling pyplot all the time, pyplot, you can just use PLT. That's fine. Okay, so for us to now plot this, we need to plot x, which is our line 6 here, which is our x-axis, to m and v that will be on vertical axis. So we have already printed the answers out in 10 and 11. So it's going to do it automatically. It's going to align them and loop through your answers and match them together. So once it matches your x to your m, it's going to then plot it against each other. That is what line 3 here is doing. The same thing happening in line 4. So it's going to pick line x, it's going to pick the value of x here, one after the other, 20 values. I'm expecting 20 values out of here. So, and also I'm expecting 20 values for bending moment and 20 values for shear forces, because it will give me more, richer point of view. So if I'm plotting that, and then I will have to show it, you have to use line 5 to display it. If you don't use line 5, it will not display. So if we display it, that is the answer you are seeing on the screen. Do you understand? And if you plot this manually, this is the same diagram you will see. So it's quite much more than this. If I'm to show you the back end to that analysis we ran, this is the analysis here. So this is how I ran it, and to show you the importance of having a lot of value. You see now, for bending moment, I have 20 values from 0 to 0. From V for shear forces, I have 20 values as well, from 50 to minus 50. So this gives me a lot of information that I can use for my design. So we are going to see this further in the BOOTCAMP, right? So for those who will be part, and why we have such much value is because of the line space we created here. We wanted 20 points of view. We want to see it from 20 points. Don't just give me 5 points, 1, 2, 3, 4, 5, because of course it's 5 meters, right? But do you know in 5 meters there are billions and millions of points for us to understand what is actually happening in each point of loading, in each point of deflection. So there is no rocket science or the applications we use. This is just a secret to them. All the mesh analysis we do in Puta structure, this is the logic behind them. All right. So if that is well understood, I will leave you to practice on your time. Hopefully you will get access to this slide. And if you are practicing along with me there, if you have questions, you can log in. Just scan the code on the screen, ask your question, then an answer will be given to you. You get. So to conclude on this, I know we've covered quite a lot. I know it's a lot of information. If I were you, I probably would not get too much of what I've been taught now, because I'm not that smart. So my head now will just be boiling and on and on and on. But it's what that you hear about this now. So you don't have an excuse to be a mediocre, to be a common engineering graduate, right? There's a lot more I would love us to learn on this. I want us to still go back from the beginning and break it down and work together. If in our post-camp, hopefully we'll have enough time, we'll work collaboratively. All right, all of us will work virtually, and you'll be running your code, I'll be running my code. We'll be working together for us to sell this, and probably we might even create an application that we might be using in the Department of Civil Engineering in University of Abuja. How do you see that? I think I would love to. Engineer Joseph, I think we can do something around that for a department. We can create something that works in our own ecosystem. So this is the beginning of a game changer for you all, and personally I'm excited. I'm in this space, and I'm so glad that we are doing this together again. So please, I encourage you all to explore further and to practice. I've shown you the workspace you can start with, and there are a lot of examples on the screen here that I will need you to practice with. And with growth and consistency, you will be great. So thank you for listening. If you have any question, you can ask me. Thank you. So Engineer Joseph, am I going straight to the next or we take a break?
Yeah, absolutely.
Sir?
Yeah, there are no questions. They said they are still absorbing. I think they have a long way to go.
Yeah, I can relate.
That's fine. So you can go ahead with the third session.
All right. So in case you want a cup of my wine,